Hello, chaps. How are you? Right. Are you ready for a bit of a heavy lesson? Okay. I had a couple of shorties, but this one's going to be a bit longer. So we are still in the business of calculating the inverse of a matrix. I already showed you half the way, half because it only works for 2 by 2. I can already tell you now the easiest way of calculating the inverse of a matrix, again, is using a calculator. It's not going to work on all these. You need those silvery, shiny ones. And I will add a video of, not myself doing it, I'll send you some cool Indian guy with a lovely Indian accent explaining how to do it. But it is definitely the easiest. And if you have a matrix which is just have numbers, okay, there's nothing wrong. You can use a calculator. There's nothing wrong with it. Okay. You still need to be able to know how to use this method, because there could be some questions. Somehow they'll make it that you have to use this method. But if there's no stipulation, they just tell you calculate the inverse of matrix, and you've got a 3 by 3. Calculator is the best way, much quicker. But before I dive into it, just one more thing. Why are we actually doing the inverse matrix? You will see that in a couple lesson time, because next lesson we're going to learn another method, which is probably easier than this one. But once we're all sure how to calculate the inverse matrix, you will see that the inverse matrix helps us to solve a linear simultaneous equation, because this is really the whole reason why we're working with matrix, at least in grade 12. Okay, if grade 11 was all about changing, remember we had these little like a little vector or a dot somewhere, and we rotated it, we stretched it, all that stuff we did with matrices. The real reason why we use matrix this year is to help us solve simultaneous equations. So what we're doing is just building a tool. Okay, you can probably see that. We first of all learn how to calculate the determinant. Now, if we know how to calculate the determinant, we'll be able to calculate the inverse matrix. And if we know how to calculate the inverse matrix, then it will be really easy for us to solve these simultaneous equations. Right, so the two main way of finding the inverse matrix is what we're going to do in this lesson and the next one. Next one will be slightly easier, but it's not like, how would I say, there is no algorithm, there is no formula. It's like messing around a little bit. Now, this way is using a formula. And the formula is actually something that most of us are really like, but the price we have to pay is that it's quite long, okay? So, first of all, I'll show you the formula, okay? Or maybe even before that, just remind you from last lesson that if I have a matrix M, the inverse matrix, if I multiply them together, I get the identity matrix. That's where we need to always start. That's the definition of the identity matrix. Now, here's the formula, right? So to find the inverse matrix, no problem. Just 1 divided by the determinant of M times the adjoint of M. Okay. So 1 over the determinant of M, we know what it is. We know how to calculate the determinant of M. It's not easy, but if we have a calculator, it can be quite easy. So we're just dividing it by the determinant of M. What is ADG? What is the adjoint of M? Okay, that's where the trickiness comes to. So to find the adjoint, first of all, the adjoint of M is also a matrix with the same dimension as M. So our aim will be to find the inverse matrix of this 3 by 3. I'm not going to ask you to do 4 by 4. That's insane. I can't see them asking you to do a 4 by 4 matrix. So we'll go with 3 by 3. And the inverse matrix is also going to be 3 by 3. And the adjoint matrix, which I'm going to show you how to calculate, is also going to be 3 by 3. So how do we get to the adjoint matrix? Because we understand the determinant, that's okay. How do we get the adjoint to that? So we start with, the M. Okay, that's your matrix, M. First step, this step we already have, right? We've got an M. Okay, we've got a matrix that we want to inverse. The first thing we need to do is find the minors of this matrix. That's also the same dimension. So this is 3 by 3. That's also going to be a 3 by 3 matrix. And actually we spoke about that. Then we're going to take the minors, the matrix of the minors, and we're going to turn it into the cofactors, which is very easy. Again, we mentioned that. Don't worry, I'll remind you. Then we take the matrix of the cofactor, which is also 3 by 3 in this case, and then we're going to do transpose, which we also know how to do transpose. And that means that's the adjoint, okay? So I should actually write that as equal, okay? So if I did the minus cofactor transpose, that means I got to the adjoint. And then all I got to do is divide by the determinant, and voila, I got my inverse. So let's start. Okay, so I need to find the matrix of the minors of n. Okay, so what is the minor? Okay, so I'll start with a minor. Okay, minor of n. Okay, that's also going to be a 3 by 3 matrix. And each entry, the entry here, will be basically the minor of that. Now, what is the minor of that? Remember what we do is we take the row, we draw a line or a hand, okay? We work with hands, okay? We draw a line or a hand, horizontal or vertical, and we end up with, in this case, 2 by 2. And what we're going to do is just find the determinant. Okay, so I'm not going to write that down. Shall I write it down? It's going to take too long. I mean, I think we can just calculate it. Okay, this entry is basically the determinant of this. Okay, so let's write that down. What's the determinant of this? Is 1 times 1. Okay, maybe I'll just write one thing. Okay, so this business here, okay, this entry is the determinant of 1, 0, minus 1, 1. Okay, what is the determinant of this? This is 1, it's 1. Okay, you see that? Okay, maybe let's do one more time, and then we're gonna make it a little bit quicker. Okay, so what is going to be the second entry? Well, the second entry, I'm gonna put a line through here and through there. Okay, and what I'm ending up with is these 4. Okay, can you see those 4 numbers? 2, 0, 1, 1. And I need to find the determinant of this one. Okay, so 2 times 1 is 2. So this entry is 2. Okay, I'll just pause here to make sure I got it right and clear out, and we're going to go quicker now. Okay, so the third entry, I'm going to block these things, and you can see I'm end up with this determinant, this matrix, and the entry itself is the determinant of this matrix. So 2 times minus 1 is minus 2, minus 2, minus 1 is minus 3. Okay, I'm going to just check every time because it's so easy to make a mistake here. A1, A1, oops, A1, B1, it is, A1. Yeah, I don't know. Is it minus 3? Yes, it's minus 3. I'm hoping. Okay, next one, we're looking for this one. So what is that? I'm going to put these, and you know what? I'm just going to write it to make it safe, okay? So this one is the determinant of minus 2, 3, minus 1, 1, okay? And by the way, like I said, I'm in page 135, so you can follow this. The calculation is there. So if you don't understand exactly what I'm doing, just read it as you go along. Okay, so the determinant here is minus 2, minus 3, so it's plus 1. So I think I've got 1 here. And I just want to make sure I'm getting it right. Yeah, so far I think it's looking good. Okay, then let's look at this one. Okay, yeah, I'll do it. I'll carry on. I'm not being lazy. Okay, so the determinant, so this entry is going to be the determinant of 1, 3, 1, 1. Okay, see what I've done? I've just blocked these guys, and that's 1 minus 3, it's minus 2. Okay, and then this one, okay, is the determinant of 1 minus 2, 1 minus 1, which is minus 1 minus 2 is plus 1, I think. Okay, and then let's just erase a little bit. Okay, I'll just pause and make sure we haven't made any mistakes so far. Okay, so last 3 entries. Right, come on, Mr. Lisha. Okay, I'm going to hide this code. So I'm going to have a determinant of minus 2, 3, 1, 0. Okay, that's 0 minus 3 is minus 3, which I think was right. Yeah, yeah. And then this one, okay, so I'm going to hide these guys. So I'm going to have 1, 3, 2, 0. And the determinant here is 0 minus 6. So that's going to be minus 6. And the last one, okay, if I'm hiding this one, this entry is, I have to hide that. And I'm going to have the determinant of 1 minus 2, 2, 1, which is 1 plus 4 is 5. So I'm getting a 5. Okay, let's have a quick check. Yeah, I think it's okay. I think it's okay. Right. All right. So we've got the matrix of the minors. This is the matrix of the minors of n. Okay. Now we need to get into the cofactor. Okay. So let's write down cofactors of n. Okay. This one to find the minors is the hardest thing. The rest is a piece of cake. Minus is the hardest thing. Take for it. It does. It really does. Okay? But the rest are easy. The cofactors, if you remember, I think I mentioned that word, is basically the same as the minors, but just putting, using the alternate sign. Remember? So I'll use green. Okay? So we decide, and I know I'm completely aware that this doesn't really, you don't understand why we're doing it. Okay? But the first entry is always plus. Okay? And then it's alternate. Plus, minus, plus, minus, plus, minus, plus, minus, plus. It's just an alternate sign. So the matrix of the cofactor of n is the same as the minus, and we just time it by a certain sign. So plus times 1 is just 1. This is going to be minus 2. This is going to be minus 3. You see, we're not swapping everyone. This from 2 became minus 2, but this minus 3 remained minus 3. Then this is going to be minus 1, minus 2, minus 1, minus 3, plus 6, and plus 5. I'm just going to quickly check that we haven't done any stupid mistake. That's fine, 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 fine. All good, all good. Okay? So I'm going to put another tick for the cofactors. We've done that. Okay? Next bit, next station is the transpose. Okay? So we're going to transpose. I'm going to just be a little bit lazy. And I'm going to transpose it here. Now we're not transposing n, we're transposing the cofactor. So I'll write down transpose of cofactor of n. Okay? So what is that going to be? Well, okay, you keep the diagonal the same. Okay? Right? 1, minus 2, and 5. And as I told you guys, you could just swap these two, you swap these two, you swap these two. I just want to also say, some people, in my mind, that's how I think about it. But often in textbook, what they will say, which is the same thing, is that you swap rows to column. Okay? What does that mean? So this first row, 1, minus 2, minus 3, the first row will become the first column. So 1, minus 2, minus 3. Okay? Some people prefer to do it like this. So the first row becomes the first column. Okay? The second row will become the second column. So that's going to be minus 1, minus 2, minus 1. See that? I'm writing it like this. The third row now will become the third column. Minus 3, 6, and 5. But it's essentially it's the same thing. You see, all I did is I swapped those two. And those two. Well, they're the same, so nothing happened there. And those two. Okay? Right. Okay, so we have the matrix, and we found the minors. We found the cofactor. The minus was the hardest. The transpose, easy. Okay? And then I'm done, really. I'm actually completely done. Okay? So I'm just going to pause to make a little bit of space. Or in fact, I can probably do it now. Yeah. Okay. So once I've got the transpose, that means, like I said here, it's equal to the adjoint. That's the adjoint. The transpose of the cofactor of the minors is exactly that joint. So I'm going to just write down the formula, okay? So the inverse of n, if this is n, is 1 divided by the determinant of n. Now, you're going to excuse me, I'm not going to actually calculate the determinant of n. I'm just going to take it from the book. I just need to see where they wrote it. Where did I write it? Okay, the determinant of m is minus 4, okay? So they did it for us, so it's 1 divided by minus 4. So we still need to calculate the determinant of n, but you can try that video that I showed you how to use a calculator to find the determinant of n. It really will take you just 2 minutes to do it. Okay, so we found the determinant of n, and I'm going to multiply by the adjoint of n. But what is the adjoint of n? That's the adjoint of n. Okay? It's the transpose of the cofactor of the minors of n. Okay, so we're going to time it by 1, minus 1, minus 3, minus 2, minus 2, 6, minus 3, minus 1, and 5. Right? And if you don't mind, I'm just going to move that minus over to here. Okay? Now, at this point, really, we're done. We're done. And this is actually important for you to know. If you asked to find out the matrix, the inverse matrix, it doesn't mean you need to multiply this quarter. So, right, minus quarter, plus a quarter, plus 3/4, minus. You can, but you don't have to. We can write down, we can leave a matrix, inverse matrix like that. Okay? And in fact, I think it's going to be easier. Okay? So I'm going to just pause, and what we still need to do in this video is to show that if I multiply that by that, we'll get the identity. So let's do that. Okay, so as I just said, what we're going to try, what we need to show now that this formula is actually correct. So this formula is correct. That if I did that, I'm going to get a matrix, this one, that if I multiply it by the original matrix, I'm going to get ones and, identity matrix. So what I can do here, and hopefully you're not going to be too cross with me, you can see that, this is called a scalar. It's just a number. I can just move it to the other side. Okay, because multiplying this scalar by all these entries is the same as multiplying the scalar by, instead I can just multiply it by these entries, or I can just multiply these two matrices and multiply the matrix that I'm getting by minus quarter. So I'm just going to move it minus quarter to this side and then start multiplying these two, if that makes sense. I'll write it again okay, it will take me just a second. I think it's worthwhile just making sure that you understand that you can do it, okay? So I can multiply that by 1, minus 1, minus 3, minus 2, minus 2, 6, minus 3, minus 1, 5. And I tell you what, let's just leave it like that. Let's keep it simple, okay? So let's write that down. That's minus a quarter. Because, if I multiply this 1 minus a quarter by a certain one of the matrices, just by 1, then I'm going to get like 5 over 4. I don't want that. Okay? Right. Now let's start work. Okay. So we need to, this entry, okay, should be really 1, is can come about by multiplying this row by this column. Okay? So 1 times 1 is 1, plus 4 is 5. 5 times, no, again, I'm getting something wrong here. Hey, guys. 1 plus 4 is 5. Yes, that's fine, calm down. Okay, so 1 times 1 is 1. Minus 2 times minus 2 is 4 is 5. So 5. 5 minus 9. What is 5 minus 9? It's minus 4, isn't it? So I'm getting minus 4. Okay, guys, I'm probably not going to do all of it because it's going to take a long time, but I'm going to do some of it. Okay, so why minus 4? Initially, I thought like, oh, minus 4, that's not good. I should get 1, isn't it? Okay, but I mustn't forget I need to multiply by minus a quarter. So we already, if I'm multiplying that, okay, so whatever that matrix that we haven't really, we only just started. Next thing I need to do is multiply this minus quarter by each one of these elements. And minus quarter times minus 4 is 1. So the first one is good. Let's do one more on this entry, okay? So this entry will be done by multiplying the first row by the second column, okay? So 1 times minus 1 is minus 1. Minus 1 plus 4 is 3. 3 plus 3 times minus 1 is 3 minus 3 is 0. So I'll go at 0 here. Let's do one more on this row, and then maybe I'll do one more, and then that's it. Okay? Because I'm bound to make a mistake, right? 0 times minus a quarter, that's going to be 0 anyway, so I'm done. Okay? Now, the third entry is this one, okay, is going to be the first row from the third column. Okay, 1 times minus 3, minus 3, minus 3, minus 12, right? Minus 3 minus 12 is minus 15, and that works out because 3 times 5 is plus 15, so I'm getting a 0. Okay, 0 times anything will be 0. Right, shall we do maybe one more entry to find a 1? So I'm thinking doing that middle one. Okay, the middle one will be your second row times the second column. So 2 minus 1 is minus 2, plus 1 times minus 2 is minus 4. Minus 4 plus 0 times minus 1 is minus 4. So here I've got minus 4. Again, minus 4 times minus a quarter will give you 1. And your homework, if you want, you can just carry on and check that everything else really is 0, apart from this, which hopefully will also be minus a quarter, meaning this is 0, 0, 0, 0, and 1. Okay? Right? So, look, you don't have to do it. I think it's probably a good idea to do it, just to try. Okay? The rest of the exercise, you just got a bunch of matrices, 3 by 3 matrix, and you find their inverse. Okay? So, hopefully that made sense. Just to recap, and I'm really actually sorry that I deleted it, maybe write it again. How did we find the inverse matrix? First of all, we found the determinant. Okay? Next thing, I had the in. I did what did I do? The minors. I did the matrix of the minors, which was the difficult thing. Okay? We had to find the minors. I need to do that. I'm ending up with a 2 by 2 matrix. Find the determinant of that, and that was the minors. Okay? Then comes the easy bit, cofactors. Okay? Now alternate sign, plus minus, start with plus, and then minus, plus, carry on. Okay? That's the cofactors. And then we did the transpose. Okay? We took the matrix of the cofactors, we swapped each row to become a column. And that was basically your adjoint. That was your adjoint. We divide by the determinant, and we got the inverse. Hurrah!